Welcome to this lesson on command line arguments. You need to remember that the C programming language was developed by Kernighan and Ritchie to support their building of the Unix operating system. If you've ever executed commands at a Unix system prompt, or at an MS-DOS prompt for that matter, the command that you type and any information that you include on that line becomes your command line. Typically, a command line consists of a program name followed by one or more parameters. Copy file A to file B. Those things become the command line. And so the operating system passes that command line to our programs. Because C was built specifically to support an operating system that used a system prompt, C has tremendous command line processing capabilities. In this lesson, we'll drill down into those. And so again, we've got some examples of commands being typed at a system prompt. We've got the type filename.txt, cd to the home directory, copy source.txt to target.txt, delete filename.ext. All these are examples of different command lines. And when we execute a command from the system prompt, the operating system passes that information to our program. So let's take a look at a C program that doesn't support command line arguments, and we'll see how it differs from one that does. In our first program code, we'll see that main has got the int main, and then within the parentheses it says void. That tells us that the program is not supporting any command line arguments. If we use a word to run the program and specify command line arguments, the program's just going to ignore them. It's not going to use them. It just exists to specify the message hello world to the screen display. The second example, however, changes our main function declaration. And so you can see that it supports two arguments. The first is an integer argument called argc. You can think of that as being short for argument count. It specifies the number of parameters on the command line. So if we had a change directory home, there would be two, the change directory command itself and the home directory. The second argument is an array of pointers to character strings. That's the actual command line arguments. It will always start with the program name that's running, followed by the first parameter, second parameter, third parameter. So it's just an array of character strings. And so this first program, when it runs, it's going to display the count of the number of command line parameters. And so you can see it's displaying the message argc is 1. That's because we ran it without specifying a command line. We're just running it in my little environment here, so it's impossible to specify a command line. But argc is 1 because the program name itself counts as a command line argument. In the second program, we're extending it a little bit more. And we've got, again, we're passing the same parameters to main in the same order. Our int argument count will always come first, followed by our array of pointers to character strings. And so it's an array. We know it's zero-based index, which means the first element is at index 0 within the array, and that should correspond to the name of the program that's currently running. And in this environment, and in a lot of Unix environments, that program is called a.out, and it's got a name that's pretty similar to that. And so when it runs, it's displaying that first command line argument. Again, in this environment, I can't pass other information in the command line. I'd need a different compiler to create a program that I could run from a command line. But it helps us take a look at the code. And so our second program, again, looks similar. And so you can start to familiarize yourself with the format int main, then int with the argument counts, followed by a definition for an array of character string pointers. In this case, if we had a command line, copy file 1 to file 2, delete file 1, type file 1, all those things would be part of our command line. And so we just could simply use this for loop for I equals 0. Our first command line argument is going to be at index 0, the program name. As long as I is less than the number of arguments that were passed on the command line, go ahead and print the character string that that command line argument is passed to. Now in this environment, we only get the first one. That's okay, but it shows us that argv points to a program with the out extension, some kind of executable program on this string. And so it'd be great to grab this source code and take it to one of the web-based compilers that lets you specify a command line. And then you can run the program with the command line parameters and watch how you can loop through the argv array to display each one of them. Now in future programs, we'll use the command line arguments to maybe display the contents of a file the user specifies on the command line. And so we will open a file that's specified by argv1. And so there's a lot of different ways that we can use command line arguments. Kind of your imagination is the limit. But a common application that you'll see in C programs is just simply to echo the command line arguments to the screen as you're getting started. And that's what this program does. Now, as you look at different programs that support command line arguments, you may see argv declared differently. In this first case, we've got our main program. It returns a value of type into the operating system. It's getting an integer parameter that specifies the number of command line arguments, and then it has a pointer to a string. And so you've been through our pointer lecture, hopefully, and so pointers are becoming more familiar. The double asterisks tell us that it's a pointer to a pointer, and in this case we can loop through this using a simple for loop. Again, each one of the arguments, and we can treat that pointer as a pointer to a string, we can treat that pointer as an array. There's several different ways to use it. The most common is shown here below. Let me scroll down to it. Where we're just simply going to do an increment of the pointer until it finally points to null, which indicates the end of our string. And so our command line now is what gets past the main is an integer value that specifies the count of number of command line arguments, argc, and then we have a pointer to a pointer, when we increment it, it points to the next pointer, and when we increment that, it points to the next pointer. So by incrementing that pointer, we can loop through each one of the command line arguments. In this case, we can't pass command line arguments to it in this environment, so we only see that first command line argument, which is our program executable. But you'll see this format, and so don't let it panic you when you see it. It's just a pointer to a pointer, and it's going to be as common to see argv declared as a pointer to an array of character strings, or as the pointer to strings, as shown here. But take some time to play with it and convince yourself that really whether you use an array or whether you use a pointer, you've got the same functionality. And so although you'll normally see things declared as int main, int argc, char argv, there's nothing special about the names argc and argv. And so in this case, I've just declared main as getting a integer parameter, we'll call it a. It happens to contain the count to the number of command line arguments, and array of pointers to character strings that we'll call b. And so using these, we can still loop through our command line. So we're using the names a and b to get to the command line arguments. So there's nothing special about argc and argv. They're just names of local variables in the main function. And so for good practice, you should always call them argc and argv, because that's what every other C programmer does. It's consistent. But in actuality, as you can see here, there's nothing special about those names. So now we're having a little bit of fun. We're going to actually use the command line arguments to do some processing. And so you can take a look. We've got our int argc and we've got our argv, array of pointers to character strings. And so the first thing the program does is takes a look. Did they specify at least two parameters? The goal of this program is to display the contents of the file the user specifies in the command line. So if they don't specify at least two command line arguments, then they probably only specified the program name, so we can't have a file to open. They didn't provide us with one. So the first thing we do is we display a syntax error message, no file was specified. If they do specify a file, our else portion of the code executes, and now we do some file processing. That should look familiar from the file processing we did in that lecture. We have a file pointer that corresponds to the file that we open. Now look at the name of the file that we're opening. It is the character string that's pointed to by the second command line argument, argv index of 1. We're opening it in read mode. As long as the file pointer is not null, we can loop through it. If the file pointer is null, we can display a message that says, hey, we had an error opening the file pointed to by argv1. If we don't, we have a buffer that we're going to read data into, and we just use fgets to read a line from the file, fputs to write it to standard out. When we're done looping and looking at all the file's contents, we close the file. So here we've got 15 to 20 lines of code, but it does some interesting processing. It uses a command line to get a command line argument, the file they want to display, and then it does our traditional file processing. So all things you now know how to do is starting to come together. In a similar way, this program deletes the file that they specified on the command line. So again, we should get at least 2 command line arguments, the name of the program and the file that we want to delete. So within our program, we first see, is argc less than 2? If it is, they have an invalid syntax command. They didn't specify a file to delete. Otherwise, we'll try to remove the file they specified. It's pointed to by argv sum 1. And as long as remove doesn't return a 0 value, we know that error occurred, so we display a message, error deleting the string that's pointed to by argv sum 1. Otherwise, we display a message that says the file was deleted. And so again, we've got 10 lines of code, but it does some pretty interesting processing. It uses command line arguments. It uses the remove function to delete the file. Remove is part of the standard C library, so we can quickly remove a file that's specified. And so now you're starting to see almost how a lot of the Unix system prompt commands work. And so this would be kind of similar to a delete or a remove command. And now we're talking a lot of fun. We've got a program that displays the first n lines of the file specified in the command line. And so the format is first the file name and then the number of lines that we want to display. And so our main definition looks the same. We've got int argument counts and then our array of pointers to character strings. And then we've got a buffer that we're going to read data into from the file. So that's our line 255. We've got I and j variables that are going to be counting variables to help us keep track of how many lines we've read and how many lines are left to display. We've got a file pointer that's going to be used to read data from the file. And so our syntax in this case is if argc is less than 3, then they use the wrong syntax. They should specify the program name, the file name, and the number that they want. Otherwise, we try and open the file that's pointed to by argv1, and we're opening it in read mode, as you can see. And if that's equal to null, then we know we had an error. Maybe the file didn't exist. So we display the error message, error opening the file pointed to by argv1. Otherwise, we use the atoi. And atoi is an older function that's built into the standard C library that converts an ASCII to integer. That's what the atoi stands for. And it's taking that value that's pointed to by argv sub 2, which should be a value like 5 or 10 or 25, and it's converting it from a character string to an integer. It's assigning it to j. And so now we can have a little for loop that loops for I equals 0, as long as I is less than the number of characters they want displayed. Read a line of the file and display it. And so we're just going to kind of loop through. If they want 5, we're going to loop through 5 times. Well, if they want 50 and there's only 25 lines in the file, at some point in time we're going to reach end of file. So you can see that the fgets function is checking to see if null got returned. And so as long as, if null got returned, then it's going to break, which causes the loop to break and the program to end. If it didn't return null, then it's going to use fputs to output the line. So we've got a couple of things going on in that loop. One, we're checking to make sure that I is less than the number of character or number of lines they want to display. And the fgets is making sure that we don't get an end of file before that count of the number of lines gets reached. And so that's why we're breaking out of the loop. And normally I don't like to break out of loops. I like to code differently. But this actually came out pretty clean, and it's pretty readable code. And so, and again, 25 lines of code or something, we've got a quite functional utility. Here we have a program that's going to rename the first file specified to the second file name specified. So it's kind of rename old file name to new file name. And so our main program, our main function, gets a count of the number of arguments, and then it gets an array of pointers to character strings. And it looks at the syntax and says if argc is less than 3, you didn't specify the rename command, the file you want renamed, and the new file name. So you've got a syntax there. Otherwise, it's going to use the C standard library rename function to rename them. And if rename can't, it'll return a value not equal to 0. And so we can display a message that said, hey, we had an error renaming the file that you want to rename. Otherwise, it's just going to display a message that said, yep, renamed them. And so even fewer lines of code, but using command line processing, we're able to create something that's a pretty valuable utility. So since we're talking about main and command line arguments, I thought it'd be a good time to revisit main's return value. And so the value int that precedes main says we're returning an integer value to the operating system. The way that we do that is using a return statement. So in the first example, we're returning the value 0 to the operating system. That's normally an indication that the program ran successfully and it's just executing or exiting normally. In the second case, however, and so if we go ahead and run that first one, the program just runs, it doesn't display anything because we don't have any printf statements. In the second case, we're returning the value 255. That might be some kind of error status. Maybe we can open a file, we couldn't rename a file, but we want to tell the operating system, hey, we had a problem. So why would we want to tell the operating system? Because somebody may be running this program from some kind of shell script, and they can check the value that the program exits with and perform processing within the script as they need. And so in this case, we're returning the value 255. In this environment, the code will actually say, hey, you exited with a value 255. I normally see 0. 0 is good, but just calling to your attention that the program executed or exited with a value of 255. And so here's how we could use it within a real program. In this case, you can see if they have a syntax error, we return the value 1 to the operating system, primarily to a script that might be running. If we couldn't rename the file, we return the value 2. And if we successfully rename the file, we return the value 0. And so now we're communicating with the operating system, and more importantly, scripts that are running within the operating system. And it allows them to have a degree of programmability based on the exit status or the success status of our program. So what we learned next, we learned command line arguments in this lesson, and they give us quite a bit of functionality. When you execute a command from the system prompt, operating systems typically let you redirect the command's input from the keyboard or redirect the command's output from the screen display. So for example, the first command says, I want you to run the dir command, the directory listing command, and pipe the output of the command to become the input of the more command, so we'll display the directory listing a screenful at a time. In the second case, we're saying run the dir command, but redirect its output from the screen display to the file named files.txt. So our directory listing is going to be written to a file as opposed to the screen. In the next lesson, you'll learn how people write C programs that support such I/O redirection. And we'll learn that there's several predefined file pointers, standard in, standard out, standard error, that we make extensive use of as we try and write programs to support this kind of redirection.